A cylinder block is an integrated structure comprising the cylinder, S, of a reciprocating engine and often some or all of their associated surrounding structures. The term engine block is often used synonymously with cylinder block. In the basic terms of machine elements, the various main parts of an engine, cylinder head, S, coolant passages, intake and exhaust passages, and crankcase, are conceptually distinct, and these concepts can all be instantiated as discrete pieces that are bolted together. Such construction was very widespread in the early decades of the commercialization of internal combustion engines, and it is still sometimes used in certain applications where it remains advantageous. However, it is no longer the normal way of building most petrol engines and diesel engines, because for any given engine configuration, there are more efficient ways of designing for manufacture. These generally involve integrating multiple machine elements into one discrete part, and doing the making for multiple elements in one setup with one machine coordinate system. This yields lower unit cost of production. Today most engines for cars, trucks, buses, tractors, and so on are built with fairly highly integrated design, so the words monoblock and en-block are seldom used in describing them. Such construction is often implicit. Thus engine block, cylinder block, or simply block are the terms likely to be heard in the garage or on the street. Development context: the move from extensive use of discrete elements to extensive integration of elements was a gradual progression that passed through various phases of monoblock engine development, wherein certain elements were integrated while others remained discrete. This evolution has occurred throughout the history of reciprocating engines, with various instances of every conceptual variation coexisting here and there. The increase in prevalence of ever more integrated designs relied on the gradual development of foundry and machining practice for mass production. For example, a practical low-cost V8 engine was not feasible until Ford developed the techniques used to build the Ford flathead V8 engine, which soon also disseminated to the larger society. Today the foundry and machining processes for manufacturing engines are usually highly automated, with a few skilled workers to manage the making of thousands of parts. Cylinders integrated into one or several cylinder blocks. A cylinder block is a unit comprising several cylinders. In the earliest decades of internal combustion engine development, monoblock cylinder construction was rare. Cylinders were usually cast individually. Combining their castings into pairs or triples was an early win of monoblock design. Each cylinder bank of a V engine typically comprised one or several cylinder blocks until the 1930s, when mass production methods were developed that allowed the modern form factor of having both banks plus the crankcase entirely integrated. A wet liner cylinder block features cylinder walls that are entirely removable, which fit into the block by means of special gaskets. They are referred to as wet liners, because their outer sides come in direct contact with the engine's coolant. In other words, the liner is the entire wall, rather than being merely a sleeve. Wet liner designs are popular with European manufacturers, most notably Renault and Peugeot, who continue to use them to the present. Dry liner designs use either the block's material or a discrete liner inserted into the block to form the backbone of the cylinder wall. Additional sleeves are inserted within, which remain dry on their outside, surrounded by the block's material. With either wet or dry liner designs, the liners can be replaced, potentially allowing overhaul or rebuild without replacement of the block itself. But in reality, they are difficult to remove and install, and for many applications, an engine will never undergo such a procedure in its working lifespan. It is likelier to be scrapped, with new equipment a Euro engine or entire vehicle a Euro replacing it. This is sometimes rightfully disparaged as a symptom of a throwaway society, but on the other hand, it is actually sometimes more cost-efficient and even environmentally protective to recycle machinery and build new instances with efficient manufacturing processes than it is to overvalue old machinery and craft production. Cylinder blocks and crankcase integrated. Casting technology at the dawn of the internal combustion engine could reliably cast either large castings, or castings with complex internal cores to allow for water jackets, but not both simultaneously. Most early engines, particularly those with more than 4 cylinders, had their cylinders cast as pairs or triplets of cylinders, then bolted to a single crankcase. As casting techniques improved, an entire cylinder block of 4, 6, or 8 cylinders could be cast as one. This was a simpler construction, thus less expensive to make. For straight engines, this meant that one engine block could now comprise all the cylinders plus the crankcase. Monoblock straight fours, uncommon when the Ford Model T was introduced with one in 1908, became common during the next decade, and monoblock straight sixes followed soon after. By the mid-1920s, both were common, and the straight sixes of General Motors were prying market share away from Ford. During that decade, V engines retained a separate block casting for each cylinder bank, with both bolted onto a common crankcase. For economy, some engines were designed to use identical castings for each bank, left and right. The complex ducting required for intake and exhaust was too complicated to allow the integration of the banks, except on a few rare engines, such as the Lancia 22 or 1/2 degree narrow-angle V12 of 1919, that did manage to use a single block casting for both banks. The hurdles of integrating the banks of the V for common, affordable cars were first overcome by the Ford Motor Company with its Ford Flathead V8, introduced in 1932, which was the first V8 with a single-engine block casting, putting an affordable V8 into an affordable car for the first time. The communal water jacket of monoblock designs permitted closer spacing between cylinders. The monoblock design also improved the mechanical stiffness of the engine against bending and the increasingly important torsional twist, as cylinder numbers, engine lengths, and power ratings increased. Most engines made today, except some unusual V or radial engines, are a monoblock of crankcase and all cylinders. In such cases, the skirts of the cylinder banks form a crankcase area of sorts, which is still often called a crankcase despite no longer being a discrete part. Engine blocks are normally cast from either a suitable grade of iron or an aluminium alloy. The aluminium block is much lighter in weight, and has better heat transfer to the coolant, but iron blocks retain some advantages and continue to be used by some manufacturers. Because of the use of cylinder liners and bearing shells, the relative softness of aluminium is of no consequence. Combined block, head, and crankcase, light-duty consumer-grade Honda GC family small engines use a monoblock design where the cylinder head, block, and half the crankcase share the same casting, termed uniblock by Honda. One reason for this, apart from cost, is to produce an overall lower engine height. Being an air-cooled OHC design, this is possible thanks to current aluminum casting techniques and lack of complex hollow spaces for liquid cooling. The valves are vertical, so as to permit assembly in this confined space. On the other hand, performing basic repairs becomes so time-consuming that the engine can be considered disposable. Commercial-duty Honda GX family engines have a more conventional design of a single crankcase and cylinder casting, with a separate cylinder head. Honda produces many other head block crankcase monoblocks under a variety of different names, such as the GX V series. They may all be externally identified by a gasket which would bisect the crankshaft on an approximately 45-degree angle. Exhaust valve failure is common and, owing to the monoblock design, so labor-intensive to repair that the engine is normally discarded. Engine block, transmission case, and rear axle housing as frame members. Many farm tractor designs have incorporated their engine block, transmission case, and rear axle housing as frame members. Probably the first was the Fordson tractor, but many others followed. As with many other instances of integration of components into fewer castings, lower unit cost of production was the driver. See also, core plug, head gasket, long block, short block, references. Bibliography, Sorensen, Charles E. With Williamson, Samuel T., My 40 Years with Ford, New York, USA, Norton, LCCNA 56010854A. Various republications, including ISBN 9780814332795.